You may savor the sweetness of honey daily, but did you know that this delicacy stems from the meticulous craftsmanship of a remarkable creature, the bee? These seemingly tiny insects possess a complex social structure, efficient task allocation, sophisticated communication skills, remarkable navigational abilities, and diverse behavioral patterns. Let's delve deeper into the mysteries of the bee world and gain a deeper understanding of these tiny creatures. Bees are quintessentially social creatures, living together in a large family of thousands of individuals called a hive. Within this family, there is only one female bee capable of laying eggs, the queen of the hive. Besides the queen, there are a few male bees capable of mating, known as drones or stingless bees. The majority of the hive's members are female bees. Infertile workers. Worker bees shoulder numerous responsibilities, including collecting pollen and nectar, brewing and storing honey and beeswax, guarding and cleaning the hive, and caring for larvae and the queen. Within a beehive, different types of bees perform their respective roles and collaborate closely, forming a highly organized and stable social system. Worker bees undergo different work phases throughout their lives, flexibly adjusting their duties based on their age and physical condition. Typically, worker bees spend their first 3 weeks busy within the hive, performing various household tasks such as cleaning cells, feeding larvae, reinforcing nest walls, and processing pollen and nectar. These tasks are collectively referred to as housekeeping. Starting in the 4th week, worker bees begin to engage in external tasks such as foraging for pollen and nectar, exploring new resources, and defending the hive. Around the 6th week, due to wing wear, worker bees and their short but busy lives, bees use a variety of methods to communicate, including chemical, tactile, acoustic, and visual signals. The most well-known of these is their dance language. Worker bees use specific body movements to communicate to their companions the location of food resources they discover while foraging. This dance language primarily takes 2 forms: the round dance, used to indicate food resources close to the hive within approximately 100 meters, but with unclear directions, and the waggle dance, or figure 8 dance, used to indicate food resources farther away over 100 meters, but with clear directions. In the waggle dance, worker bees trace a figure 8 pattern on the hive wall. The straight line points in the direction of the food resource, and the angle with the vertical indicates the food resource's azimuth relative to the sun. The length of the line and the frequency of the waggle dance reflect the distance to the food resource. The farther away, the longer the line and the higher the frequency of the waggle dance. Other worker bees can observe and imitate these dance movements to accurately locate the food resource. When foraging, bees must be able to accurately locate food resources and return safely to the hive. To achieve this, bees possess remarkable navigational abilities, using a variety of cues to determine their position and direction. The sun is a crucial cue, and bees use its position and movement to determine direction. However, the sun is not a constant reference. It changes position over time. To address this challenge, bees possess an internal mechanism called a diurnal clock, which calculates the sun's current position based on its position at birth and the current time. In addition to the sun, bees use other cues, such as topography, landmarks, magnetic fields, and polarized light, to aid navigation. By combining these cues, bees can accurately locate and navigate in complex and ever-changing environments. Beyond their routine activities of gathering, building, and caring for their hive, bees exhibit remarkable behavioral patterns that demonstrate their intelligence and remarkable adaptability. For example, during the cold winter months, bees gather tightly together in their hive, forming a compact, spherical cluster known as a winter mass. Within the winter mass, the temperature in the center maintains a constant temperature of approximately 35 degrees Celsius, while the outer regions can drop below 10 degrees Celsius. To maintain this ideal temperature, worker bees in the center generate heat through muscle contraction, while those in the outer regions squeeze air to create a thermal barrier. Furthermore, worker bees constantly rotate within the winter mass to ensure that each worker enjoys a comfortable temperature and adequate rest. For example, when hive space becomes cramped or environmental conditions become unfavorable, bees adopt a strategy called swarming. At this point, an existing colony splits into 2 or more new colonies, each seeking a new nesting location. During swarming, The existing queen bee leads a group of worker bees out of the original hive and temporarily settles on nearby branches or structures, forming a temporary colony known as a transient swarm or dark box swarm. Simultaneously, new, unmated female bees, called virgin queens, hatch in the original hive. These virgin queens fiercely compete with each other, even attacking each other, until only one victorious virgin queen remains.